Okay, now we will see low pass filter and high pass filter with the step input. In our previous class we have discussed about low pass filter and high pass filter with sinusoidal input, and we have given the conclusion that wave shaping has not been occurred, and we have seen frequency response also. And in this particular case, as I said, step input we are going to give as an input for the low pass filter and high pass filter, and we are going to see what are the outputs we are coming. Okay. And wave shaping will be done in this particular case, we are going to analyze that one. So, before going to start this particular concept, I want to tell, by taking one electrical circuit which is actually low pass filter and high pass filter combination I am going to take. That means I will not tell that particular electrical circuit is a low pass filter or high pass filter. The analysis will be done on the electrical circuit which is having again resistor and capacitor only, and we will take some conclusions from that particular electrical circuit analysis, then we can use that one, or that particular analysis will be helpful to understand this low pass filter and high pass filter with the step input. Okay. So, I am taking one electrical circuit which is actually containing the series connection of resistor and capacitor, and for this one I am giving a step voltage I am giving as input 5 volts at t is equal to 0. That means before t is equal to 0, no voltage was given for that particular circuit, and exactly at t is equal to 0, suddenly I have provided 5 volts, and after t is equal to 0 also 5 volts is there, and it is simply series connection of two elements R and C. Okay. Now, we are going to analyze this particular circuit in terms of voltages. Because it is a loop, okay, because it is a loop, we can apply KVL. So, from the KVL I can write supply voltage is equal to voltage of the resistor and voltage of the capacitor at t is equal different times I am calculating now. Okay. When t is equal to -1 second, that means before application of the step voltage only. Okay. So, step signal is nothing but we are applying like this, 5 volts is applied at t is equal to 0 and 0 volts is there before t is equal to 0. So, t is equal to -1 means the supply is 0, capacitor is uncharged. So, resistor voltage 0, capacitor voltage is also 0, just this mathematical expression we are going to analyze. Okay. Now, t is equal to 0, exactly t is equal to 0, supply is becoming 5 volts. Listen carefully now. Okay. This is a key point. At t is equal to 0, supply is changed to 0 to 5 volts. So, I am taking 0 plus only, t is equal to 0 plus only. So, supply voltage is 5, but the capacitor does not allow sudden changes in voltages. In our beginning classes I have told, capacitor does not allow sudden changes in voltages. Suddenly we have provided voltage 5 volts at t is equal to 0. So, capacitor will not take this one. So, whatever the voltage is there previously, that is 0 volts, will be maintained as it is. That means capacitor voltage now also it is 0 only. Okay. But KVL is to be satisfied. KVL definition if you observe, at any time, it may be t is equal to -1, it may be t is equal to 0, it may be t is equal to 1 second, 2 second, 10 seconds, at any time KVL is to be satisfied. That means Vs must be equal to Vr plus Vc. So, now Vs is 5 and Vc is not taking that voltage, that means Vc is 0. So, to satisfy the KVL or to satisfy this mathematical relation, the Vr must be 5. That means what is the meaning of this one? Suddenly at t is equal to 0 we have provided the discontinuity, suddenly at t is equal to 0 we have provided 5 volts. So, that 5 volts is suddenly taken by the resistor only, not by the capacitor. Okay. So, capacitor does not allow sudden changes in voltages, that statement we have used here, but a resistor can take sudden changes. Okay. So, now I am giving the statements. So, listen carefully, capacitor does not allow sudden changes in voltages, it will maintain the same voltage before the sudden change. How much voltage is there, same voltage will be maintained after the sudden change also. that is about the capacitor, but capacitor allows the sudden changes in current. Now coming to inductor. Inductor does not allow sudden changes in current. Inductor allows sudden changes in voltage. Now coming to resistor. Resistor allows sudden changes in voltages and currents. Okay. Now coming to this particular discussion only. So at t is equal to 0 we have provided sudden change in voltage. So capacitor does not allow sudden changes in voltage. So whatever the previous voltage 0 is there, same voltage will be maintained by the capacitor, that is 0 only. But to satisfy the KVL, VR is equal to 5. Next, we have given that 5 volts continuously now. After t is equal to 0, supply voltage is 5 only. So I am giving 5. Now time is equal to 1 second, t is equal to 1 second. Now what will happen? Capacitor starts charging. Okay. When the capacitor will be charged, I have given that also. Okay, that particular point also I have given. Capacitor will be charged in the closed loop. Capacitor will be charged when the supply voltage is more compared to the capacitor voltage. Now the capacitor voltage is 0 only, Vc 0 only, but supply is 5 volts only. Okay, 5 volts is larger compared to capacitor voltage, so that capacitor ready to charge. Capacitor charges to 1 volt within this particular 1 second. For example, within 1 second the capacitor has been charged up to 1 volt. This is for example only. Okay, capacitor is charged up to 1, but supply is 5 volts. Now you see KVL is to be satisfied again. Okay, so to satisfy the KVL, what I need to put in this particular blank? Compulsory 4. 5 is equal to 4 plus 1. That means capacitor is charging, that is okay, but resistor voltage is getting decreased. Don't say resistor is discharged, that is the wrong statement. Resistor voltage is decreased to 4 volts. Now time is going on. Now the time at t is equal to 2 seconds. Still the supply voltage is 5 volts only. Within this time capacitor is charged up to 2 volts now. Okay, to satisfy the KVL, resistor voltage is decreased to 3 volts. Time is at t is equal to 3 seconds. Supply is 5 volts. Capacitor is charged up to 3 volts. So resistor voltage must be decreased to 2 volts. Time is t is equal to 4 seconds. So capacitor voltage must be charged up to 4 volts. Supply voltage is 5. Capacitor voltage is decreased to 1. Next, time is 5 seconds. Capacitor voltage is 5 volts. Supply is 5 and resistor voltage is decreased to 0. Okay. Now it is continuously like this only. So now the time is for example 10 seconds. Capacitor is can able to charge up to 5 only, because supply is 5. So capacitor can be charged up to 5 only, because capacitor itself is charging from the supply. Supply is 5, so it will be charged up to 5 only. That 5 volts will be maintained like this only. Supply is again 5 volts only. Resistor voltage again 0 only. It is maintaining like this only. Okay, at t is equal to infinity also we will see the same structure now. That means Vc is 5, Vr is 0, Vs is 5. Now if you observe this particular concept, what is happening to the capacitor voltage from t is equal to 0 onwards? What is happening to the resistor voltage from t is equal to 0 onwards? If you observe, capacitor voltage is increasing. Okay, capacitor voltage is increasing from 0 to 5 volts. Resistor voltage is decreasing from 5 to 0. Okay. So mathematically if you see, we can tell capacitor voltage Vc is increasing exponentially, resistor voltage is decreasing exponentially. This concept you remember. Okay. Now we will see with our PDC subject point of view. Low pass filter we have to take, high pass filter we have to take. Generally at first, why did I take this particular circuit? Series connection of resistor and capacitor. Okay. Series connection of resistor and capacitor itself is a low pass filter or high pass filter. Now you are familiar with the low pass filter circuit, I am taking again. So this is low pass filter and this is high pass filter. You observe these 3 circuits now. On the screen you have 3 circuits. One is series connection of resistor and capacitor. Second one is also series connection of resistor and capacitor. Third one is also series connection of resistor and capacitor, but the orientation of the elements are different. Okay, orientations are different in 3 different circuits, but the content is same. For this circuit, if you apply the same step input, for this circuit also if you apply the same step input, same thing is happening. But in case of the low pass filter, we will take output across the capacitor. So, if you take output across the capacitor, this itself is acting as the low pass filter output. If you take output across the resistor, this is acting as the output of the high pass filter, output of the high pass filter, nothing is there. Okay. So, 3 circuits are same circuits only, this is what you need to remember, 3 circuits are same circuits only. Already we have completed low pass filter operation and high pass filter operation for the step input, over that analysis already we have done. Okay, capacitor voltage, if you talk about the capacitor voltage, that is nothing but you are talking about the output of the low pass filter, because in case of the low pass filter we are taking the output across the capacitor only. If you talk about resistor voltage, that is nothing but you are talking about the output across the output of the high pass filter, because in case of the high pass filter we are taking output across the resistor. Okay. Now, but in actual procedure we will do what is to be written in the examination, that is what I am going to tell here, that is again by using the Laplace transforms only. Okay. So, I am taking in this particular circuit only, otherwise I will draw here 5 volts, generally I have given 5. So, for the derivation purpose I am taking V step voltage we are giving, okay, V into U of t, that is representing the step voltage, V volts we are giving. This is R, this is C, and here V naught of t is there, and here also we are giving V volts U of t, and this is a capacitor C, resistor R. Circuit needs ground, every time you have to draw ground. Okay. Next, now to analyze the output, we are converting this particular circuit into S domain. So, already we are familiar with that one, resistor will be R only, but capacitor impedance is given by 1 by Cs in the S domain, and here V naught of S will become V naught of S, and this V is constant and U of t Laplace transform is 1 by S. Okay. Next, coming to this particular circuit, high pass filter, the impedance offered by the capacitor in the S domain is 1 by Cs, and the resistor is R, it is grounded, across the resistor R only we are taking the output, that is V naught of S, and input is V by S, similar to the previous case. Okay. Now, apply voltage dividing rule to get the output. So, V naught of S is equal to supply voltage V by S into, we are taking output across the 1 by Cs, and total impedance is given by 1 by Cs plus R. Okay. And you can take a Cs as a LCM, and numerator Cs, denominator Cs will be cancelled. You are going to get 1 by 1 plus RCS. We are familiar with 1 by S plus A, like that. So, we are taking this RC is common. So, what you get RC, if you take common, V by RC, here 1 by S and 1 by S plus 1 by RC, like this we will get. Okay. Now, we can do partial fraction, it is just to calculate the inverse Laplace transform, output already there with us, but that is there in the S domain. Now, we need to get V naught of t, for that purpose we need a inverse Laplace transform, for that purpose this partial fraction method we have to use. So, I am taking this part 1 by S into 1 by SC plus 1 by RC, this part I am taking, and I am calculating partial fractions. Okay. So, 1 is equal to A into S plus 1 by RC plus B into S. If you take S is equal to 0, you will get simply A is equal to RC. If you take S is equal to minus 1 by RC, you will get B is equal to minus RC. Okay. This is simple calculation. Okay. So, what is 1 by S into S plus 1 by RC means, we can write by taking RC common, RC into, open the bracket, 1 by S minus 1 by S plus 1 by RC. So, we can write like this, V by RC, RC by 1, 1 by S minus 1 by S plus 1 by RC, like this we will get. RC will be cancelled, V times, okay. You are now apply inverse Laplace transform. 1 by S means what is the inverse Laplace transform? U of t. So, U of t I will write later. So, 1 minus 1 by s plus a, inverse Laplace transform is e power minus at u of t. What is a here? 1 by RC. So, e power minus a t, a is 1 by RC. So, t by RC we will get into u of t. So, anyway we are working on right side only, so no need to write u of t. So, this is the output you are getting for the low pass filter. Across which element we are taking the output? Capacitor. Now, you come to the previous concept. Capacitor voltage, what I did, what I say, capacitor voltage is increasing exponentially. This is also representing exponential increment in the voltage only. So, capacitor voltage is increasing. So, mathematically also we have proved. Okay. Coming to the high pass circuit, in the similar manner we have to do. So, if you apply the voltage dividing rule, V naught of S is equal to, you will get total voltage V by S into, we are finding across R by total impedance is R plus 1 by CS. Okay. Like this we will get. Next, you can take LCM. So, what will you get here? V by S and RCS by 1 plus RCS. As I said earlier, we need coefficient of S is 1 only, because if it is in the form of 1 by S plus A, we can write e power minus a t u of t. For that purpose, we are taking RC is common, but before that S and S will be cancelled. So, if you take RC is common, numerator RC will be cancelled. So, you will get 1 by S plus 1 by RC. So, it is very simple calculation. So, if you apply now inverse Laplace transform V into this inverse Laplace transform of 1 by S plus A is e power minus a t, that means e power minus t by RC. So, this is the output. So, you see the outputs. Output of low pass filter for the step input, that is V volts, is V into 1 minus e power minus t by RC, and for the high pass filter the output is given by V into e power minus t by RC, exponentially decreasing signal, and for the low pass filter exponentially increasing signal. Okay. Now again I am drawing the circuits, no need actually. So, this is a low pass filter circuit, this is high pass filter circuit. We are analyzing for the step input. Now, what are the equations we got? V naught of t is equal to, for the low pass filter we got V times 1 minus e power minus t by RC, and in case of the high pass filter we got V naught of t is equal to V times e power minus t by RC. Okay. Now, concentrate on RC, that is actually time constant. Time constant is represented with tau, that is equal to product of resistance and capacitance. If you observe here, we are telling the product R and C is time constant. So, time means it is measured in seconds. Actually, ohms, resistance means ohms, capacitance means farads, but we are telling the product is seconds. How it is possible?